Hi Bio4 and welcome to part 3 of urinary. I just shown you this picture of the glomerulus, right? Lots of little capillaries that are going to be the filtration site. So this is a diagram that shows a bunch of them, and we're going to look at these in more detail. This is just a filtration system. So for vocab, each one of those little balls there that you see is going to have a little arteriole that's arriving, afferent arriving, and it's going to come in here to this mumbo jumbo of twisty turn artery, and then it's going to exit out in a different, in that area also. But in the meantime, it's left behind a lot of fluid because it's filtered that fluid out. So that's what you have to remember. You have to remember you have an afferent arteriole coming in, an efferent arteriole coming out. Okay? Now, notice the size difference. The afferent arteriole is way bigger. So the entryway is bigger than the drain. What do you think that's going to do to pressure? If you have an entryway that allows a lot of fluid in, and then the exit that allows very little fluid out, this is going to increase the pressure in here, and it's going to leak out of those little leaky capillaries, correct? So that's what you're thinking of. It's creating its own pressure, and it's going to leak out of these capillaries. Now it's going to leak out and go where? It's got to get trapped, right? It's got to get trapped inside a little bag. And that little bag is here in the title. It's the Bowman's capsule. So that Bowman's capsule then is this area here. And notice it comes all the way around. So any kind of filtration that's leaving the inside of this ball of yarn of capillaries is going to drop into this bag, into this little container, right? And that's the Bowman's capsule. That filtrate is now going to become what is eventually urine, but it's not urine yet, because for now we're just going to call it a filtrate. And then it's going to undergo all sorts of other changes in these tubes, and those changes are going to be mostly retaking most of that fluid back, because we filter 160 liters and you can't urinate out 160 liters. So this is the mechanism. Filter a lot and then reabsorb most of it back and then urinate out just a tiny bit. Okay? That's kind of the mechanism. So that visceral layer is made of this Bowman's capsule, right? The parietal layer is this bag, and then the inner layer, the visceral layer, is made of these cells, these podocytes that cover the arterioles and also form little filtration slits. So they are really sort of the capillary, and the cell that covers it, makes up that coating on those little arterioles, is called a podocyte. Podo because it looks like it has lots of legs that come out. Let's see if you can see it in the picture. Not really in this one. We'll be able to see it in another one. Here we go. So this is a cell body of a podocyte, and it's got its podos, which is its legs, its extensions over it. And these are all the afferent and efferent arterioles. Kind of a weird structure. What's going to come next is the nephron. So look, if we filtered right here, right? What's going to come next is all these tubes that go down, they loop around, and then by the time you get to here, you have urine. But what's happened before that is that you have reabsorbed most of that fluid back, left behind the stuff you don't want, get rid of the urea, right? Get rid of those toxins that you filtered out. But if it's just water, then we're going to filter it back out of the nephron and back into the blood system so that our 5 liters of blood don't get lost. So fluid, in this picture, the afferent is the low one, right? Because it's broader. Coming in, filter it out, it's going to land here, and it's going to go all the way down this section of tubes in order to become urine. And we have millions of these nephrons. Okay? I think what I want to do let's go a few more slides here. So if this is afferent coming in, notice in the inside now how through these filtration sites, this is going to all filter out and land in this capsule here. Okay? All of it is coming in here, and then it's going to go on to the second section. And the second section has a name. It's called the proximal convoluted tubule. Okay, proximal because it's closest, convoluted because it really does take a lot of twists and turns, and it's a tubule because it's a tube. Okay, let's stop there, and then we'll continue on because the nephron, I have a lot to say about the nephron. Thanks for listening. Bye.